Mastering Formula Transformation, Unlocking the Power of Algebra. Welcome everyone. Today, we are delving into the fascinating world of formula transformation in mathematics. Formulas are the backbone of many disciplines, from physics to finance. Understanding how to manipulate them is crucial for problem solving and innovation. Let's embark on a journey to unravel the secrets of changing the subject of a formula. Changing the subject of a formula involves rearranging the formula to express a different variable as the subject. It's like solving a puzzle where we rearrange pieces, variables, and operators to reveal a new picture, the desired subject. This skill is invaluable in various fields, empowering you to adapt formulas to fit different scenarios.
We have some examples to go through right now. Let's check one of the examples we have. Change of subject. Now we're looking at some examples, making y the subject of the formula. A, we have a 4y. These are some of the examples we're going to go through. We have a 4y equals to x minus 8. B, we have an mv equal to 3x plus 3y. We have a C, 3j equals 2y plus 3 all over m. D, we have a 7m equal 4y plus 8 all over m minus 3. Now let's see how we can do this. Let's take the first example. Now we have 4y equals to x plus minus 8. 4y equals to x minus 8. Let's look at this. First of all, we now look at 4 is the only thing preventing us from making y the subject of the formula here. So the first thing we're going to do here is to try and eliminate 4 from the program. So we have y. We have to do, what do we have to do here? We have to divide both sides by 4. Now, dividing both sides by 4, how does it come up with? We have y equals to 8 minus x minus 8 all over 4. So this one is the answer for this calculation. First, what did we do? We first of all took y, 4y equals to 8. Now we knew that 4 has to go for y to exist alone. So what do we do? We now took 4y, we now divided both sides by 4. Dividing both sides by 4 eliminates the 4 that is by the side of y. So this gives us an answer of y equals to 8 x minus 8 all over 4. Still making y the subject of the formula. Now let us look at this other example. The second example we have on our list is mv equals to 3x plus 3y. Now, in this example, we first of all see that there's a need for y to move to the other side, because what we are looking for is your y should always be on the left-hand side to allow every information to be on the right-hand side. Let's see how we solve this problem now. First of all, this is the value of what we are trying to solve. We go in from this thing. What do we do first? Transfer these two information to the left hand to allow for this y to be at the end at the left hand side. Now let us look at this. Now this one is 3x plus 3y equals to mv. It is still the same thing, but it was turned the other way around. Now, in turning it the other way around, we are trying to see something. We are trying to see how we can make sure that y is still in the equation and y is on the left-hand side, which is our standard definition that we gave at the beginning. Now, what comes in next? We subtract. We want to now take all the elimination little by little. We have to first of all remove 3x. 3x has to be removed first. This 3x will be removed by subtracting both sides. So how do we do that? We do it like this, making sure that this will subtract with this and this will subtract with this. Let us see how it looks. This is 3y equals to mv minus 3x. This is how it looks right now, because we know very well that we are still trying to get y to stand alone. Is to divide both sides by 3. If we divide both sides by 3, now what are we trying to do? We are trying to eliminate the 3 by the side of y. So this is what we have at the end. Now let's go to the third example. Still making y the subject of the formula. We have 3j equals to 2y plus 3 all over m. First, there's an m here, and also the y is on the right-hand side. What do? We want to try and bring y to the other side to make it easier and simpler for us to work with. Look at how it looks. The whole system, it has not changed anything. We have just succeeded in bringing the y to this side because we want to work on the y, so we'll bring it back to the left-hand side. Now, the next thing to do is to multiply both sides by m. Let's see how it looks. This is what we're going to get. Now, this is the equation after multiplying both sides by m. So, in multiplying both sides by m, you have succeeded in cancelling this m on both of the equations. This is how it will now look. Now, the next thing we should be considering is, what is the next thing to do here? We have to subtract both sides by 3. Subtracting both sides by 3 eliminates the positive 3. So let us do that. Now, this is how it comes out. We now find out that we have 2y, which is 3 is out, equal to 3j m minus 3. Now, the information tells us now that we have 2y, which is equals to 3j m minus 3. This tells us that for us to get only y on this side, we have to divide both sides by 2. Let us see how it looks. This is how it looks. So this is supposed to be almost the final stage. These questions can be very simple if well handled. So this is the answer. Right. Now this is the fourth and last example. We are still making y the subject of the formula. We have another one. Now we have seen this kind of example before. I will have given it as a form of a homework for us to really go through this. I know that your exams are coming very soon. Most of these things will be tested in the exams. So I would want you to subscribe to enable you to get more information on all these calculations. Most of these calculations will be treated very, very softly so that it will enable you to be able to do mathematics very easily. As much as I can make most of those informations more simpler on any calculations you have. Send your information on the comment box, and also send any information that you think, or any problem that you think that you might come out in your exams that you want us to be able to solve for you. We are going to try and make sure that most of the things we are doing are handled very well so that we could go further. Let's do this example. We are on the fourth example. Let us see how we tackle this. Now, looking at this thing, y is still on the right-hand side. So we want to bring y on the left-hand side. Bringing y to the left-hand side, does it change anything? No. It only helps us to realize that y should be on the left hand when trying to make y the subject of the formula. Now, looking at what we have like this, we already know that the next thing to consider, which is to multiply both sides by m minus 3. Multiply both sides by m minus 3. Now, this will also help us to get the answer. But in most cases, it's advisable to bring it to the other side. But in this case, we have already tried to solve it, and we have started solving it with m multiplied on both sides to help it eliminate the m on the other side. So let's just continue like this for now. Now we have multiplied both sides by m minus 3. What does that one help us to eliminate? M minus 3 at the bottom. Now let us look at the next thing. This is how it comes out to be. 3, m minus 3 has been eliminated, which helps us to make this easier when transferring it to the other side. Let's do the transfer to the other side. Now we move this other number, this other entity to the left-hand side. So what do we have here? We have 4y plus 8, which has already eliminated m minus 3. Let us go further. What did we do next? We subtracted both sides by 8. 4y will now be left alone. Let us see how it looks. It has 4y, which is equal to 7wm minus 21wm, which is multiplying the value to our former value, which was m minus 3. What do we still do? Because we know that y cannot be complete like this. The next thing to do is to try and find out what do we do to make y stand alone. We still have to do what? Divide both sides by 4. Let's see how it looks when dividing both sides by 4. Now, this is how it looks. Now, dividing both sides by 4, we now have something like this. So, what are we trying to do? We're trying to eliminate the 4 on the left-hand side. This is how it looks after the total answer. So, we have y standing alone on the left-hand side. Thank you very much.
Hi, everyone. Today we're going to be learning about logarithms. Logarithms are a mathematical operation that is the inverse of exponentiation. In other words, logarithms tell us what exponent we need to raise a base to in order to get a certain number. Have you ever heard of logarithms? They may sound intimidating at first, but fear not. In this video, we will be mastering logarithms together, providing you with a comprehensive guide for beginners. End of this video, you will be able to 1. Discover the relation between indices and logarithms. 2. Define the logarithms of a number and the logarithms of a number from graphs and tables. 3. Using tables of logarithms and anti-logarithms to perform basic operations on numbers greater than 1. Relationship between indices and logarithms. Indices and logarithms are closely related mathematical concepts. An index is a power to which a number is raised, while a logarithm is the inverse of an index. In other words, the logarithm of a number is the power to which another number must be raised to equal the first number. For example, the index of 2 to the power of 3 is 8 because 2 raised to the power of 3 is equal to 8. The logarithm of 8 to the base 2 is 3 because 2 raised to the power of 3 is equal to 8. Next, we will delve into the various properties of logarithms. Understanding these properties is crucial as they form the foundation for solving logarithmic equations and simplifying expressions. Throughout the video, we will provide clear explanations and examples, making sure you grasp each concept before moving on. We want to ensure that you not only understand logarithms, but also feel confident using them in your own calculations. Use them in your own calculations. To further enhance your learning experience, we will solve practice problems together. Defining logarithms. Let's start by defining logarithms. The logarithm of a number n to the base b is the power to which b must be raised to equal n. This is written as the log n to base b. Let's write a complete equation for better understanding. The logarithm of n to the base b is equal to the power to which b was raised to get n. Let's assume the power was x. See how it is written. Here are some of the laws of logarithms and indices. Logarithm of power. The logarithm of a power of a number is equal to the product of the logarithm of the number and the power. For example, the logarithm of 81 to the base 3 is 4, because 3 raised to the power of 4 is equal to 81. Logarithm of a product. The logarithm of a product of two numbers is equal to the sum of the logarithms of the two numbers. For example, the log of 81 multiplied by 27 base 3 is equal to the sum log of 81 base 3 and the log of 27 base 3. Now, the logarithm of a number to a given base is the exponent to which the base must be raised to obtain that number. Log 81 base 3 is equal to 4, and log 27 base 3 is equal to 3. Therefore, the sum of the two numbers is 7. Logarithm of a quotient. The logarithm of a quotient of two numbers is equal to the difference of the logarithms of the two numbers. For example, the log of 81 divided by 27 base 3 is equal to log of 81 base 3 subtracted by log of 27 base 3, because 3 raised to the power of 4 minus 3 equal to 81 divided by 27, which can be written as log 3 base 3, and let's assume it is equal to x. Therefore, 3 raised to power x is equal to 3 raised to power 1, x equal to 1. Now, method 2 of the same equation. Let's start by separating the information log 81 to base 3 is equal to x, 3 raised to power x is equal to 81, which is also equal to 3 raised to power x is equal to 3 raised to power 4. The 3 is cancelled, therefore x is equal to 4. Similarly, log 27 to base 3 is equal to x, 3 raised to power x is equal to 27, which is also equal to 3 raised to power x is equal to 3 raised to power 3. The 3 is cancelled, therefore x is equal to 3. Therefore, log 81 to base 3 minus log 27 to base 3 is equal to 4 minus 3, where 4 is gotten from log 81 to base 3 and 3 is gotten from log 27 to base 3, which is equal to 1. Let's go through some things we learned about logarithms. Study these things. If you have any problem, send a comment so we can work on them and help you improve. Throughout this tutorial, we will break down logarithms from their basic definition to their various properties and applications. We will explore how logarithms help solve exponential equations and unlock their significance in various fields such as science, engineering, and finance. Our experienced instructor will guide you step by step, providing clear explanations and real-life examples to ensure a complete understanding. Use of graph in logarithms. Graphs can be used to visualize logarithmic functions and to understand their properties. The graph of a logarithmic function is a curve that has the following characteristics. It has a vertical asymptote at x equals sine 1. This means that the function approaches infinity as x approaches 1. It increases as x increases, but at a decreasing rate. This means that the function values get larger as the x values get larger, but the rate of increase slows down as x gets larger. The shape of the graph depends on the base of the logarithm. For bases greater than 1, the graph is concave up. For bases between 0 and 1, the graph is concave down. This topic will be treated completely in my next video. Subscribe to get more information about this and more. Thank you for joining us on this journey to master logarithms. We hope you found this video helpful and informative. If you did, don't forget to give us a thumbs up and subscribe to our channel for more educational content. Welcome to P and T Smart Mind. Today we will be talking about simultaneous equations. Before I go further, please subscribe and hit the notification bell. Now let's start the lesson. Simultaneous equation. Two equations with two variables taken together are called simultaneous equation. Simultaneous equation could have the equation to be linear, or one could be linear and the other quadratic. For this teaching would assume that both are linear. When both are linear, they can be solved using any of the three methods. 1. Substitution. 2. Elimination. 3. Graphical. The first two methods would be considered. Let's start with substitution. What is the substitution method? Substitution method. In the substitution method, you solve one of the equations for one variable and then substitute that expression into the other equation. Here's a step-by-step guide. Step 1. Solve one of the equations for one of the variables in terms of the other variables. Step 2. Substitute the expression obtained in step 1 into the other equation. Step 3. Solve the resulting equation for the remaining variable. Step 4. Once you've found the value of one variable, substitute it back into one of the original equations to find the value of the other variable. Step 5. Check your solution by verifying it satisfies both equations. Now, let's take some examples on substitution methods. Example 1. Solve the simultaneous equation using the substitution method for x minus y equals 11 and 5x plus 2y equals 4. Solution. Let 4x minus y equals 11 be equation 1 and 5x plus 2y equals 4 be equation 2. From equation 1, let's make y the subject of the formula. Y is equal to 4x minus 11. This would be taken as equation 3. Now substitute equation 3 for equation 2. 5x plus 2, open bracket, 4x minus 11 bracket close is equal to 4. This can then be written as 5x plus 8x minus 22, which is equal to 4, which is reduced to 13x minus 22, which equals 4. 22 will be moved to the left side, which is now changed to positive. 13x equals 4 plus 22. 13x equal 26x equal 2. Now let's find y from equation 3. Y equals 4x minus 11 and x equals 2. Y equals 4 times 2 minus 11. Y equals 8 minus 11. This means y equals minus 3. So x equals 2 and y equals minus 3. Elimination method. In the elimination method, you manipulate the equations to eliminate one of the variables. Here's how it works. Step 1. Multiply one or both of the equations by suitable constants so that the coefficients of one of the variables in both equations become additive inverses. That is, one positive and one negative. Step 2. Add or subtract the equations to eliminate one of the variables. Step 3. Solve the resulting equation for the remaining variable. Step 4. Once you've found the value of one variable, substitute it back into one of the original equations to find the value of the other variable. Step 5. Check your solution by verifying it satisfies both equations. Let's try another example. Let's call this example 2. Solve the simultaneous equation by the elimination method. 20x plus 3y equals 4. 3x minus y equal minus 5. Now the solution, let's assume that 20x plus 3y equals 4, which is equation 1, 3x minus y equals minus 5, is equation 2. Multiply equation 2 by 3. This gives us the following. 9x minus 3y equal minus 15 is equation 3. Now add equation 1 and 3. 20x plus 3y equals 4 plus 9x minus 3y equal minus 15. This gives us a value of 29x equal to minus 11. Now divide both sides by 29, which gives 29x divided by 29, which equals minus 11 divided by 29. Note that we divided both sides by 29. Therefore, the answer is x equals minus 11 divided by 29. Now let's try to find y. From equation 2, 3x minus y equals minus 5. Put x equals minus 11 divided by 29 into equation 2. 3 times minus 11 divided by 29 minus y equals minus 5. Minus y equals minus 5 plus 33 divided by 29. Because both sides are added by 3 times minus 11 divided by 29. Using an LCM of 29, minus y equals minus 145 plus 33 divided by 29. Therefore, minus y equals minus 112 divided 29. I equals 112 divided by 29.